Hello and welcome to this video on finding the mean, median and mode of histograms and frequency polygons. Let's get started. So we're now going to calculate an estimate for the mean of this data for this histogram. So again it says that it shows the ages of 25 children on a school trip, and here's our histogram. So we know that frequency density on our vertical axis is equal to the frequency divided by the class width. So if we want the frequency, we have to do frequency density times the class width. So if we just work those out, frequency density of the first bar 1, class width 1, 2, 3, 4, 5, 6, 6 times 1, 6. Frequency density of the second bar 3, class width 1, 2, 3, 4, 5. 5 times 3, 15. Last bar, frequency density of 2, class width 1, 2. So we multiply those and we get 4. Then, like we do every time we calculate the frequency, we very quickly check, does what I've calculated add up to the frequency that I should have if they give us that in the question. 6 plus 15, 21 plus 4, 25. We're okay. Okay then, so now we can move to calculating an estimate for the mean. So what was the mean? Well, a lot of the times it's just said as the average, but obviously mean, median and mode, they're all averages as well. But the mean, really, add them all up, divide by how many there are. So how do we apply that idea to a histogram? Well, we have this equation here at the bottom that I've written. So we've got sum of the frequency times the midpoint over the sum of the frequency. So what does that mean? Well, what does the midpoint mean? I suppose that's the burning question. Well, we take the midpoint of our class width and then we times that by the frequency. Right, okay, so how do we go about doing that? Well, what is our class width here? 1, 2, 3, 4, 5, 6. And it ran from 5 to 11. So we take the midpoint of that. How are we going to do that? Well, if we add 11 and 5 and divide that by 2, it will give us the midpoint of that class width. So 11 and 5 is 16 divided by 2, that's 8. So the midpoint of that is 8. The midpoint of the second bar, well, we've got 11 and 16 as the boundaries, if you like. So if we add those together, 16 plus 11 divided by 2, so I'll just write that out. 11 plus 16 divided by 2, and that is 13.5. And then the last one, well, obviously we can add the two together, so the 18 plus 16, and then divide that by 2. But we know the midpoint of these three numbers is 17. So I'll write it out anyway, but we know that it is 17. So 16 plus 18 divided by 2, which is equal to 17. So just running back through that. So we take the midpoint of our class, of our interval. So if we can't just see it, what the midpoint is, we can just add the two numbers at the ends together, divide by 2, and that will give us the midpoint. Okay, so then we have to take that midpoint and times it by the frequency. So for this first bar, we'd be doing 8 times 6. And 8 times 6 is 48. So in fact, I'm just going to write this over here. So so we've got the sum of the frequencies of the frequency times midpoint. So I'm just going to abbreviate that to F and then mid. So sum of frequency times the midpoint. So that's going to be 6 times 8. And remember, it's the sums, we've got to add them together. So 6 times 8 plus 13.5 times 15. Because remember, in these numbers in red that I've written on the bars, they're the frequencies. And then the last one, just writing equals there actually. So then the last one will be 17 times 4. So if we just get a value for that and we'll write it down, so obviously go to your calculator. So 6 times 8 plus 13.5 times 15 plus 17 times 4. And that pops out at 318.5. So that's the top part of our fraction. And the bottom is the sum of the frequency. So again, I'm just going to get rid of that. So sum of frequency. So I'll just leave that as F. Well, the sum of the frequencies is 6 plus 15 plus 4. And we know from what we said earlier that that is 25. So then we just take the sum of the frequency times the midpoint, which was 318, and divide it by 25, which was the sum of the frequencies. So the mean is equal to 318.5 divided by 25. So work that out. 318.5 divided by 25. And that is 12.74. So what does that answer mean? What does that answer mean? What does our answer of the mean actually mean there? Well, it's the mean age of these school children. So the mean age would be 12.74. And obviously, like I said previously, we're happy that we can have a decimal answer for an age because we could just take so many months of their age. So 12.74 to 2 decimal places. Obviously, to 1 decimal place, if they asked in the exam, it would be 12.7. Okay, so we're going to find the median of this histogram and the data of this histogram. So it says that the histogram shows the ages of 25 children on a school trip. Okay, so every time you get a question like this, start out by writing this equation down. So that is that frequency density is equal to frequency divided by class width. So frequency density is equal to frequency divided by class width. Okay, so if we want the frequency, we just rearrange that and we get that frequency is equal to frequency density times class width. Okay, so we can jump straight in and start doing that. So the frequency density of the first part of the histogram, that's 1, and we're timesing by the class width, which is from 5 to 11, which is 1, 2, 3, 4, 5, 6. So it's 1 times 6, which is 6. The second bar, the frequency density is 3, and the class width is 1, 2, 3, 4, 5. So it's 5 times 3, which is, of course, 15. And then the last bar, the density, well, frequency density is 2, and the class width is 2, so the frequency is 4. Something worthwhile doing, add the frequencies you've calculated together and check that they equal the frequency that you should get. So 6 plus 5, so 6 plus 15 is 21, plus 4, 25. So we're happy. Okay then. So we're going to estimate the median. How do we go about doing that? Well, we know that the median is the middle value. So if you've got 25 students on this trip, the median is half of those, and 25 divided by 2 is 12.5. So we're looking for the 12.5 student. Obviously this is an estimate of the median, so it doesn't have to be entirely accurate, it is an estimate. Okay, so how do we go about doing this? Well, we know that we've got 6 students in the first bar. So that's 6 students. And then if we add 15 to that, we'll get 21 students. So we know that our 12.5 student lies somewhere within this bar here. So this, in fact, I'm going to just star it above. So somewhere within this bar here. And our job is obviously to find that. How do we find that? Well, we use this little equation down here. So this is to calculate an estimate of the median. We take the lower bound of the category it's in. That's 11. So write that over here, 11. And then we add to that the number of people into the category. Well, if we want the 12.5 student and we've already gone 6 in, if we do 12.5 take away 6, will be 6.5 into this bar here. So 6.5. And then we've got to divide that by the number of people in that category, so in that case it's 15. And then times that answer by the class width, which was 1, 2, 3, 4, 5. So we times that by 5. So that will give us our median. So if I just put median, so median, so that's equal to the lower bound, which was 11, the number of people going into the category. So remember that we were looking for the 12.5 value. We'd already used 6. So we've got to go 6.5 into this category here. So doing so, that's where we get the 6.5 from. The number of people that were in this category, so the frequency of this bar here was 15, and then we times by the class width, which was 1, 2, 3, 4, 5. So punch that straight into your calculator, so we get 11 plus 6.5 over 15 times 5, and that comes out at 13.16667. So if we just round that to 1 decimal place, we'll get 13.2. And what does that answer mean? Well, it's the median age of the school children on the trip. So the middle value, the median age of the school children is 13.2, and obviously we could have 13.2 as an age. So 13.2 as an age, well, 0.2 of a year, so it'd be 13 and 2 months. So that's perfectly fine, and that's how you'd leave your answer. The mode of this histogram. So we've done it twice already for the median and the mean, so I won't run through it again. But the first thing we need to do really with all of these questions on mean, median and mode is find the frequency. So how did we find that? Well, we times the frequency density by the class width. We got 6 for the first bar, 15 for the second, 4 for the third bar. So how do we find the mode of this data? Well, recall what the mode means. It's the most common value. So for a normal data set, it's the number that appears the most. So we just need to apply this to histograms. So when we apply it to histograms, we're in fact finding what is called the modal class. So the modal class and in order to do that, we just pick the class with the highest frequency. So what has the highest frequency here? Well, the class that runs from 11 to 16. So it would be that. However, from the grouped tables that we get with histograms, we may see our data written like this. We may see the data written like this. So we could have a mixture of inequality symbols. We could have the same inequality symbol. We could have something that looks like this. So just be very wary if you do an exam or a past paper question that you pick the right number. Obviously here we don't have a table, so we don't know what the data was originally, but it will be something that looks like one of these three. But just ensure that you pick the right one. Make sure that you've got the correct symbol. So the less than it or equal to, or just less than, or greater than or equal to, greater than. Make sure that you pick the right one. So to recap, the modal class, we just picked the class with the highest frequency. So this was the class that ran from 11 to 16, and it could look like one of these values, but obviously pick the right one from the table that you get if you're given it in the exam. Let's calculate the mean for this histogram, or an estimate for the mean. So as ever with these questions, first thing you've got to do is find the frequency. So how do we do that? Well, we know that frequency density is equal to the frequency over the class width. So the frequency is equal to the frequency density times the class width. I've already worked these out just to save time, so I'll just run through the first one. We know that the class width is 10, and we know that the frequency density is at this point here. These little divisions are 0.2, so 2.2, 2.4, 2.6, so 2.6. So 2.6 times 10, and that is obviously 26. So obviously we did a lot of that in the first part of the video, so I didn't want to waste time on that. Okay, so in order to find a estimate for our mean, we use this equation here, which is the sum of the frequencies times the midpoints divided by the sum of the frequencies. So we've got to find our midpoints. So the midpoint of 80 and 90 is 85. The midpoint of 90 and 100 is 95. The midpoint of 100 and 120 is 110. The midpoint of 120 and 140 is 130, obviously the number in the middle. It gets a bit trickier here. The midpoint of 140 and 170, well, how could we work that out? We could do 140 plus 170. So 140 plus 170 divided by 2, and that is 155. So I'll just write the answer. So 155. How could we have known that by looking at it? Well, we know that the midpoint is these two numbers, so it's halfway between, so 155. Similarly for this one, we know that the midpoint is between 108 and 190, so it's 185. Okay, so we just take all of those numbers, so the midpoints that we've just calculated, and times them by their frequencies, and add those together. So we do 85 times 26 plus 95 times 34. I'm filling those out. Just I didn't want to waste too much time on it. So that's what the top of that should look like. So just very quickly, so it's the mean that we're working out here. So it's the mean. That's equal to all of that. And then the sum of the frequencies, well, that's 26 plus 34 plus 100 plus 60 plus 42 plus 18. And that is 280. So what we do then is we punch that into our calculator. So I would just type all of it in and press equals. And upon doing that, we get 110. And I'm just going to round that to one decimal place, so 110.5. Obviously check what they want you to round it to in the question. So what does our answer mean? Well, we've calculated the mean of the test scores, so that means that the mean of the test scores is 110.5. On the median for this histogram, so it says that the Maths GCSE test scores of 280 students are shown in the histogram below. So I've jumped ahead a little bit and I've calculated the frequencies. So I'll just recap how I did that. I know that frequency density is equal to frequency over class width. Therefore, frequency is equal to the frequency density times the class width. So how did I get 26 here? Well, I know that each of these little squares is 0.2. So the frequency density here is 2.6. So it's 2.6 times the class width of 10, 26. I'll just run through another one. So for this 100 one, the frequency density is 5 and the class width is 20. 20 times 5, 100. And I'll just run through the last one here. So the frequency density here, well, each of these bars is 0.2. So if this slightly darker line is 1, that would be 0.8, 0.6. So 0.6 times 80, sorry, 0.6 times the class width, which is 30. And 30 times 0.6 is 80. Okay, so what I would do after you've calculated these frequencies is just add them up and check you get the right answer. So 26 plus 34 plus 100 plus 60 plus 42 plus 18, that's 280, and we had 280 students to begin with. Okay, so now we're going to find the median for this histogram. What is the median? Well, the middle value. So the middle value here, well, it would be half of 280. Half of 280, well, that's 140. So it's the 140th value. And how are we going to find out what that is? Well, we need this equation that we had before. So the median, if I just put the median, is equal to the lower bound plus the number of scores into the category divided by the number of scores in the category times the class width. Okay, so we are searching for the 140th value. We need to find what bar the 140th value falls in. Well, it's not going to fall in the first bar because there's only 26 values. So then we look at the second, which we, if you remember, do a kind of a running total of the frequencies as we go along. So the second bar, there's been 60 frequencies, so that's no good. But then the third bar, we'd add 100 to that. So we find that there's 160. So up to this point, there is 160 scores up to that point. So we know, therefore, that our median is going to fall in this bar here. Why is it that bar? Well, up to this point, it was 26 plus 34, which is 60. So we know that the 140th value lies somewhere between 60 and 160. Our job is to find out where it exactly falls and hence find our median. Okay, so the lower bound of this bar here, well, that's 100. And then we're adding to that the number of scores into the category divided by the number of scores in the category. Well, the number of scores in the category, well, that's 100. There's a frequency of 100 here, so there's 100 scores in this category. And we know that the class width is 20. So I've deliberately left the numerator of this fraction off because I'm going to work that out. In fact, I'm just going to rub this out, actually, what I did here. Just I think that could be slightly confusing. Okay, so I've deliberately left the numerator of the fraction off, so the number of scores into the category, because we need to work that out. So we're searching for the 140th value. Well, in this bar there was 26, in that bar there was 34. So up to this point here, there's been 60 values, and we want the 140th. So we want the number of scores into this category here. Well, how are we going to find that? Well, if we do 140, I'll just do it over here. If we do 140 take away 60, that will give us the amount of scores into that category. So how have I worked that out? Well, I've took the value I'm searching for, taken away what we already have, and that will leave me with whatever's left in this category. So we've got to go 80 scores into this category in order to find the number of scores into that category. So it's 80 on top. I'll just run through that again. How did I find that? Well, I know that in the first two categories there were 60 scores, and I want to know how many the number of scores we've got to go into that category. So if there's already 60 and I'm searching for the 140th value, I do 140 take 60 and I get 80. So it's the same as what we did before. So the median is equal to it's equal to 100 plus 80 over 100 times 20. So I'll type that into my calculator. So it's 100 plus 80 over 100 times 20, and that comes out at 116. So what does that mean? What does that number mean? Well, it means that the median score for this test was 116. So the median score for that test was the score of 116. Calculate the mode. We use the frequencies we've calculated, and we choose the class with the highest frequency. Well, the highest frequency here is 100, so therefore that modal class, so the modal class is the class with the highest frequency, which is the class of 100 to 120. Let's just assume our data was written like this. So 100, let's assume it was written something like this. So our modal class would be this. So we would write that down for our answer. So we're now going to find the mean for this frequency polygon here. When we're finding the mean for data that is in a class interval, we need to remember, I'm going to write up here, that the mean is equal to the sum of the frequency times the midpoint. So I'm just going to abbreviate midpoint to mid. So it's the sum of the frequency times the midpoint divided by the sum of the frequency. So the sum of the frequency times the midpoint divided by the sum of the frequency. Okay, so now we're going to start calculating the mean. And the first thing that we need to remember is that a frequency polygon is the frequency plotted against the midpoint, which is very helpful because the midpoints are already there. So here we've got time, and it's the midpoint of the time. So for the first point, it's the midpoint of the time, which is 10, times the frequency, which is 5, and then we would add the midpoint of the time here, which is where the point is plotted, which is 30 times 20, and so on. So we'll jump straight in and start working this out. So the mean is equal to here In fact, I'll tell you what, I'm going to write it down here. So the mean is equal to, so the first one, it's 10 times 5. Plus 30 times 20. Plus 50 times 15. Plus 70 times 25. And then the midpoint for the last one is, of course, 90, because it's between 800, so 90. And I'll just zoom in just so we can see it. So we know if this line's 5, this darker line here is going to be 2.5. So 2.5. And then we just need to work out the values of these divisions. So if we do 2.5 take away 0 and divide by how many divisions there are, so there are 1, 2, 3, 4, 5. So we're doing 2.5 divided by 5, which is, because we took 0 there, so it doesn't really matter, that comes out at 0.5. So we know that each division is 0.5. So then here, that's on the second line, that point's on the second line, so it's 0.5 and then 1. So just zoom out a bit further. So it's 90 times 1. So that's the top of our equation for the mean sorted. We've just got to do the bottom. So then the bottom is the sum of the frequencies. So we just need to add the frequencies together. And doing that, well, that will be 5 plus 20 plus 15 plus 25 plus 1. We established that one. On the bottom was 1. I would now just go ahead and put all of that into your calculator exactly as I've written it, and that will give you the right answer. So the top, so in brackets 10 times 5, the close bracket plus 30 times 20, da 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 da. And then all of that divided by 5 plus 20 plus 15 plus 25 plus 1. 49.09090. So we'll round to one decimal place, so 49.1. So that's the estimate for the mean. So what have we done there? Well, we've taken our equation, which is the mean is the sum of the frequencies times the midpoints. So we've took the frequencies, times them by the midpoints, and then divided by the sum of the frequencies, and we've got the answer of 49.1. What does that answer mean? Well, it is the estimate of the mean for this data, and that is the mean time that people spent in the swimming pool. So 49.1 minutes is the mean time that people spent in the swimming pool. So if I just put 49.1 mins for minutes, and that's the mean time that people spent in the swimming pool. So we're now going to calculate the median for this frequency polygon. I've now attached the table, so the frequency table that this data was taken from, because I think that will make it a bit easier for us to see how to calculate the median. So how do we calculate the median? Well, we begin, as we did before, we really need a sum of the frequencies. So if we work out a sum of the frequencies, so adding that together, we get 5 plus 20 plus 15 plus 25 plus 1. So 5 plus 20 plus 15 plus 25 plus 1. And those added together gives us 66. So the total for the frequency is 66. What's the median? It's the middle value. So if we take the sum of the frequency, 66, divide by 2, we get 33. So our median, so therefore, our median is the 33rd value. So that's a 3 obviously. So the median is the 33rd value. How do we find the 33rd value? Well, it is exactly the same way we did it for the histogram questions. So we just need to firstly find out what class the median is going to be in. So it can't be in the first class because there's only a frequency of 5. So we need to go as far as the 33rd value. We need to find where the 33rd value is. So we start that running total. So into the second class, well, that will have had in total 25 values to that point. Then to the next point we had 15. And that gives us, so to this class here, there's 40 values. So we're happy that it must lie in this class here. So the median lies in the class here, which is between 40 and 60, and including 60 for that matter. Okay, so how do we calculate the median? Well, we took the lower bound of that class, which was 40. Then we added how far we went into that class, so I'm just going to leave that blank on the top, divided by how many things are in that class. Well, there's 15, because it has a frequency of 15. And then we times by the class width, which is 20. How do we get from 40 to 60? We have 20. So we times by the class width, which is 20. Okay, so the problem we've got is obviously this part on the top of the fraction here. And that's how far we've gone into that class. Well, the first two classes gave us 25. And we're after the 33rd value. So if we do 33 minus 25, so I'm just going to do a little bit of rough work up here. If we do 33 minus 25, well, that will give us 8. So therefore, to find the 33rd value, we know we've had to go 8 values into this class here. So 8 values. Okay. And then this here is going to give us the median. So median is equal to 40 plus 8 over 15 times 20. So we'll type that into our calculator. To our calculator, we get the answer of 50.66666666. So it seems to be 6 recurrent. So 50.6666. So it seems to be that 6 is recurring. We're going to round to one decimal place anyway, so 50.7. And then again, the question that I've continually asked throughout this video, what does that answer actually mean? Well, it's the median, but it's the median of what? It's the median of the time in minutes that people spent in a swimming pool. So the median is 50.7 minutes. So the middle value, if you like, is 50.7 minutes. Of the following frequency polygon, we look at the table and we're looking for the modal class. So the modal class is the mode for questions like this. And how do we do that? Well, we just select the class with the highest frequency. What class has the highest frequency here? Well, the 60 to 80 class. So this class here. Obviously that's clear by looking at the frequency polygon. The highest peak, which is this here, which belongs to that class there. So that's how we find the mode. Here we have a table that shows information about the time taken for teachers to travel to work. I have gone ahead and drawn a frequency polygon for that data, and we are now going to find the mean. So we are going to calculate the mean. Okay, so how are we going to do that? Well, we recall that the mean was equal to the sum of the frequencies times the midpoints divided by the sum of the frequencies so we can dive in straight away and do that. Why can we do that? Well, we know that a frequency polygon is the midpoint plotted against the frequency. So the times here are the midpoints of the times. Obviously, for the first data piece, the time is between 0 and 10, and it's plotted at 5, so it's the midpoint. So what we will do is we will jump straight in and start working our mean out. So, for the first data point, we take the midpoint, which is 5, and we times it by the frequency, so it's 5 times the frequency, which is 10. Then we're adding to that the next data point, which is a frequency of 28, and the midpoint for that is 15, so it's 15, so it's this data point here, so it's 15 times 28. Continue with the third data point. So the midpoint of that is 25, and it goes up to 46, so it's 25 times 46. Then the third, so I'm just going to drop down onto this line here. Sorry, the fourth. So it's this point here. So the midpoint is 35, and it's 35 times 23. Frequency there is 23. And then for the last, the midpoint is 45. So it's this point here, 45, and the frequency is 12. Okay, so that's the top of our fraction for the mean sorted. Just draw a line under that. And then the bottom part is the sum of the frequencies. So we just add the frequencies together. So it's 10 plus 28 plus 46 plus 23 plus 12. So if I just type that in, so 10 plus 28 plus 46 plus 23 plus 12. And that comes out at 119. So it's all of that divided by 119. So straight into your calculator with that. So 5 times 10 plus 15 times 28 plus 25 times 46 plus 35 times 23 plus 45 times 12. And it's all of that divided by 119. And the answer 24.915 pops out. So it's 24.915, and I'll just dot. So I'm going to round that just to one decimal place. So it's 24.9. Again, what does that answer mean? Well, it is the estimated mean, and it's the estimated mean for the time that it takes the teachers to travel to work. So it'd be 24.9 minutes. That is an estimate for the mean for that data. So we're now going to find the median, or an estimate for the median for this data. How are we going to do that? Well, we will start in exactly the same way that we did with our histogram data. We will find the frequencies, the total frequency. If we add that up, so 10 plus 28 plus 46 plus 23 plus 12. So 10 plus 28 plus 46 plus 23 plus 12. And that comes out 119. So the total frequency is 119. So to find the median, we find the middle value, so we divide by 2. So 119 divided by 2. So therefore our median is the 59.5 value That is not the answer. That just tells us what we're searching for. So then, how do we find that? Well, we start adding up our frequencies. So it can't lie in the first category, in the first class interval, because there's only 10. So we start that running total like we did with the histogram. So move to the next one. Well, the summation of 10 and 28 is 38, so it can't lie there. So then we would add 46. So we're happy that it must lie in this class here. So then how do we find that median? Well, we recall that it was the lower number for that, so it'd be 20, plus how far we've gone into that, divided by the actual frequency of that class. So the actual frequency of that class is 46. And then we times it by the class width. So the class width of that is 10. So we just need to, and I've deliberately left this blank, find how far we've gone into that. Well, if we knew that it didn't lie in the first two class widths because they summed to 38. So if we already had 38, we just need to know how far we've gone into this category here. So if we do 59.5, take away 38, we're left with 21.5. So we've gone 21.5 places into that width. So this is our estimate for the median. When we work this out, this will give us the estimate for the median. So we'll put that into our calculator. So 20 plus 21.5 divided by 46 multiplied by 10. And we get an answer of 24.6739. So if I just round, I've had to write it down. So 24.6739. So I'll round that to one decimal place. So we get 24.7. Okay. Then we just establish, well, what does this answer mean? Well, we've calculated an estimate for the median of this data. This data was about the time taken for teachers to travel to work, which was in minutes. So the median is 24.7 minutes. And of course, our answer does in fact lie between this class, somewhere between 20 and 30. 24.7 is there. So we're confident that we've calculated the correct answer. The mode for this frequency polygon. So we recall that the mode, when we're dealing with class data, so class interval data, is the modal class. We're searching for the modal class. How do we find that? Well, for our histogram example, so the modal class, and for our histogram example, it was the class with the highest frequency. What class has the highest frequency here? Well, we search for the highest frequency in our table and we find that it was the 20 to 30 class. So 20 so that is the modal class. So in an exam or a test, if you're asked to write down the modal class, you search for the class with the highest frequency and you write that as the answer.